leakage fault. So in this system of protection, 2 overload relays and 1 leakage or earth relay are connected as shown. So see again, this is a delta star transformer. Here I have connected the CTs in each of 3 phases. The zoom view of the combined leakage and overload protection for transformer. So see, this is a earth relay. These are the 2 overload relay which will respond for the phase to phase faults. Now this will respond for the earth fault, and I have connected the 3 CTs in each phase. This is a delta star transformer. So the 2 overload relays are sufficient to protect against phase to phase faults, and the trip contacts of the overload relays and earth fault relay are connected in parallel. So see, I have connected the trip contacts. Now these are connected in parallel. Therefore, with the energizing of either overload relay or earth relay, the circuit breaker will be tripped. So whenever there is a earth fault, or you can say phase to phase fault, then this circuit breaker gets tripped. Hence protection of transformer against phase to phase fault and the earth fault is achieved. So in this way, the protection against phase to phase fault and the earth fault can be achieved by using the third method, that is a combined leakage and overload protection. Now fourth method is a merge price protection for transformer. Now this is the last method, and this method is very important, as this scheme is also used for the protection of generator and the protection of transmission lines. So the merge price circulating current principle is commonly used for the protection of power transformer against earth and phase faults. So the system as applied to transformer is fundamentally the same as that for the generators, but with certain complicating features not encountered in the generator application. So this is a merge price protection. See, in every protection, if it is a protection of a power transformer, or it is a protection for generator, or for transmission line feeder, etc., the part to be protected is always connected in center, and in the left and right side always CTs are connected. So see here, the incoming current should be equal to the outgoing current, and if the incoming current is not equal to outgoing current, then this will lead to the abnormal condition, and in that case that extra current will flow through the pilot wires, and that will energize the relay coil. So see here, the delta star transformer is there, which is to be protected, and here we have connected the CTs. Now the CT, now for the delta type winding, we have connected the CTs in star, but for the star type this winding, either is a secondary winding, we have connected the CTs in delta. So this has been done for that the incoming current should be equals to the outgoing current. So there are some complicating features, and their remedial measures are briefed below. Now in a power transformer, currents in the primary and secondaries are to be compared. So as these two currents are usually different, as you know, the primary for the primary winding and the secondary winding, the currents are different. So usually therefore the use of identical transformer, that is of same turn ratio will give differential current and operate the relay even under no load condition. So, this is a main complicating feature. So, for this, the difference in the magnitude of the current in the primary and secondary of the power transformer is compensated. So, how we can compensate this complication? By different turn ratios of the CT. So, we use the CTs of different turn ratio. If T is the turn ratio of the power transformer, then the turn ratio of CTs on LV side is made T times that of the CTs on the HV side. Now, fulfilled this condition, the secondary of the two CTs will carry identical currents under normal load conditions. Consequently, no differential current will flow through the relay and it remains inoperative. So, this is the main first compensation that has to be done. Now, second main complication is there is usually a phase difference between the primary and secondary currents of a 3-phase power transformer even if CTs of the proper turn ratio are used. So, what we will do, a differential current may flow through the relay under normal condition and may cause relay operation. So, this is again a second problem. So, this problem can be compensated by employing the connection given in the following table. So, for this problem we will do the connection according to this table. So, according to this table, for a delta star power transformer, the CTs on the delta side must be connected in star and those on the star side in the delta. So, you can say that if the power transformer is a star star transformer, then the CTs are connected in delta delta. If the power transformer is a star delta, then the CTs are connected in delta star. Now, similarly, for the delta star power transformer, the CT connections are star delta, and the last option is if the delta delta power transformer is there, then we have star star current transformer connections. Now, the most transformer have means for tap changing, which makes this problem even more difficult. So, tap changing will cause differential current to flow through the relay even under normal operating condition. So, this above difficulty can be overcome by adjusting the turn ratio of the CTs on the side of the power transformer which are provided with the taps. And the last problem is that there are the magnetizing inrush current in the transformer. So, this is a Merz price protection of the transformer. So, see here we have used star delta transformer. So, for this we have used delta star CTs there. Now, these are the pilot wires. Here we have connected the relay coils and that are connected to the trip circuits. So, the operation is under normal load condition, the magnetizing current is very small. However, when a transformer is energized after it has been taken out of service, the magnetizing or inrush current can be extremely high for a short period. Since the magnetizing current represents a current going into the transformer without a corresponding current leaving, so it appears as a fault current to differential relay and may cause relay operation. So, in order to overcome the above difficulty, the differential relays are set to operate at a relatively high degree of unbalance. So, in short, I can say that under the normal condition, the incoming current should be equal to the outgoing current, but if there is a fault within this zone, then the incoming current would not be equal to the outgoing current, and so that balance current will flow through the pilot wires. So, that current will energize the relay coil. So, that relay coil will give signal to the trip circuit. So, in this case the protection of transformer has been done. So remember that this merge price protection is only applicable if the fault is in between the CTs, and if the fault is away from the CTs, if you can say that to the left of this portion and to the right of this portion, then this scheme will not give protection for the transformer. So this is a numerical. So a 3-phase transformer of 220 to 11 kV line volt 11 kV volts is connected in star delta. So we have a star delta transformer having a primary voltage 220 and a secondary voltage 11 kV. The protective transformers on the 220 volt have a CT ratio of 600. So for a 220 volt side we have a CT ratio of 600, and for the 11 kV we have a CT of 5. So what would should be the CT ratio on 11 volt side? So for the star delta power transformer, CTs will be connected in delta on 220 volt side and in star on 11 kV side. Now suppose the line current on 220 volt is 600 ampere and the phase current of delta connected CT on 220 volt is 5 ampere. These two values are given. So for in reference to the above line, for the phase current we can calculate the line current for the delta connected CT. Now you can we know that IEP is equals to root 3 times IL. So this is 5 under root 3 ampere. Now this 5 root 3 ampere current will flow through the pilot wires, and obviously this will be the current which flows through the secondary of CTs on the 11 kV side. So therefore the phase current of the star connected CT on the 11 kV side is 5 root 3 ampere. Now suppose I is the line current for the 11 kV side, and therefore for the normal condition the primary power should be equals to the secondary power. So the primary side now 3 for the 3 phase 220 volt into 600 ampere, this is equals to 3 into 11,000 into I. So after solving, I is equals to 12 ampere. So the line current for the delta for the 11 kV side is 12 ampere. So we can calculate the CT ratio. This is the secondary ratio, secondary side current to the primary side current. So this is 12 upon 5 under root 3 upon solving. Now this is 1.385 raised to 1. So let us do some fill-ups. The first is earth relay have dash current settings. Now it should be lower or higher. So earth relays have lower current settings. The Buckles relay is installed between, yes, main tank and conservator. The Buckles relay can only be used with oil immersed transformer equipped with obviously conservator. For the protection of a delta star transformer, the CTs of the delta side must be connected in star and those on the star side in the delta. Now overload protection is generally not provided for the, it is not provided for the generators. The next is Buckles relay is a gas actuated relay. Now automatic protection is generally not provided for the small distribution transformers. Now pick the right word. The Buckle relay can detect faults dash oil level in the transformer. This is the below the oil level. Next is the most important stator winding fault of an alternator is, this is a earth fault. Next is balance earth fault protection is generally provided for small size generators, and earth fault current is generally less than the short circuit current. The next is Merz price circulating current principle is more suitable for generators than the transformer. Thank you.